You have like teammates from all over the world. What are your parameters and qualifications when you look for teammates?
Yeah, so obviously one is like their ability to deliver product. That's like basically table stakes, right? Like you don't, like, you're not, basically we have like, QA exams. We essentially tell them, hey, you know what, these are the technologies that we're building. Can you actually do it? So we have all these like live coding events and all that stuff, right? To be able to go through these filters, right? But really when the final thing that we really look for is not any of those. Those are table stakes. You just need it, right? That like there's no conversation about this. This is like, if you want to buy food, you just need money. Sure, like yeah, that's it, right? But the rest of the conversation is about, okay, are you a good fit for the team, right? And it's not just team as in like me. It's the rest of the organization, right? Everyone has to have like this very, very similar kind of mentality, or at least be able to work with each other in a very productive way, right? So one is like communication is important, meaning like you have to hold yourself accountable for the things that you're going to deliver, right? Because someone else is actually waiting on you to deliver that so that they can build the next piece that they need, right? So that is really the key thing that we look at, right? It's like, can you fit into this team culture, right? And our team is actually multicultural, right? And I think I benefit from it a little bit by being in the San Francisco Bay Area, because like it's super diverse here, right? We see people from all over the world, so I grew up with that kind of feel, right? So I don't have any kind of like any kind of like feeling like, okay, you know what, you're a team from a different country. It's no, like we have a lot. I have the advantage of being able to understand multiculturally how teams work, right?
Hello everyone, I'm Philip Genmoran, a junior software developer at KodeAcross. Did you know that over 50% of bugs in TypeScript projects stem from avoidable type errors? Imagine if we could reduce those errors with a few key practices today. We're going to explore exactly how to do that. Are you ready? So let's build meaningful apps to change the world. Navigating TypeScript with confidence. Key techniques for developers. First, we will have an overview of TypeScript, types, interfaces, type annotations, static typing, whatever it is. Next, we will handle the common problems developers face and how to solve them. Third, I will give you the best practices that you should add to your disposal. Then lastly, the takeaways or the summary of the whole session. Overview. This includes the basics of TypeScript. First is, of course, types. Types define the kind of values that variables, functions, and other data can hold. In this image, you can see the various ways to define types, denoted by a colon and the type. In this case, we have an age, which is a number, and this value should be a number. A name, which is a string, and this value should be a string, and so on and so forth. Next is type aliases. Allows you to create custom type names for complex types. So we have defined types for TypeScript. We have number, string, Boolean, whatever it is. But there are cases where you wanted to have your own type. Say you have, in this case, a point which has numbers, which has properties X and Y. We don't have that in TypeScript. So in order to do that, we could use what we call the type aliases, wherein we create a type called point and create an object and define each of the properties of that object. In this case, line 1, we have type point, which it's equal to an object of X and Y. And X and Y are numbers. So X is a property of point and its value should be a number. Also, that's the same for Y. In order to use this type, we just simply create a variable, in this case, a point, then we denote it by colon and the point, which is the type, and then we pass in the initial value, which is, in this case, X is equal to 10, then Y is equal to 10. That's how we could utilize type aliases. Next, we have type annotations. Lightweight ways to record the intended contract of the function or variable. Say, for example, we have a function called greeter, which accepts or consumes person, which is a type of string. Then it returns a string, which is hello person. So another line, we have a user, which is an array of numbers. And then we call the greeter function right at the bottom, passing the user, which is an array of numbers, to the greeter function. This will return an error saying that argument of type number is not assignable to parameter of type string. Why? Because we are explicitly defining what the greeter function will accept, and it is a string. What we can then do is, to fix this, we will change the person, the type of it, from string to an array of numbers, or just simply pass a string. That is type annotations. Next, we have interfaces, which is similar to type aliases but are more flexible, like extending other interfaces. In this example, I created an animal which can move, eat, and sleep. Then I created another interface for dog, which extends all of the properties of animal, denoted by extends animal. I added another function inside, or another property inside dog, which is bark. Okay? Next is static type checking. This is a feature in TypeScript which ensures that values are being used are in alignment with their declared types. So what does that mean? Say, for example, right, you create a variable which is a number, then you create a function which is, I guess, called greet function, which accepts a parameter which is of type string. And then, say, for example, you run that function passing the variable that you created, which is a number. that will immediately return an error. So that's what we call type checking. So as you can see in this example, right, to give you an idea on how that works, right? When we create an object, which is an object of containing width and height, right? Then we create another variable called area, which accesses that object's width and multiplies it by the object height. If you would have noticed, everything seems to go right, except for the misspelled height here. So immediately, with TypeScript, you would immediately see that it has errors on compile time. So it will actually return property height does not exist on type object. Did you mean height? It would actually give you the closest suggestion, right, which is height. So I think that's correct. So in this case, it solves the major roadblocks for JavaScript, which is you'd be in JavaScript you'd be able to run this, but you'll see the error like on when you run it. So in TypeScript, you would be seeing the error before you even run the application. That's one of the best things for TypeScript. Next, we have is type inference, a feature in TypeScript which allows you to infer types by simply assigning values to the variable. We've actually seen this in the previous example, this one, which contains like an object. We don't really define the type for this one because, yeah, that's the concept of type inference. So how does it work, right? So in this example, I created a variable called greeting, which has the value of hello world. So in TypeScript, typically we explicitly define the type of the variable, denoting by the colon and the type itself. So if we explicitly type this variable, we will be able to, we will need to add a colon and a string, which basically says that this greeting is a string. But in TypeScript, we're not really obligated to do that. We just simply need to pass its initial value, which is in this case a string, and TypeScript could immediately discern this as a string. So we won't be able to we won't need to be able to like add a type for this. So that's what we call type inference. Next, let's now discuss the common problems that developers face in navigating their TypeScript projects. I will also give you examples on how to solve these issues so that you could employ them next time, right? Problem A, complex union types. So I'll just discuss this image, right? So first, I created a type called horse, which has a method called gallop here. Then another type of called bird, which has a method, which accepts a method called fly, right? Then next, I created a function called move, which accepts an like a union type of horse or bird. Then basically it returns void. And the return, I'm accessing the gallop function or the gallop method of a horse, which in this case will return an error because we don't know if gallop exists on bird. So basically it will return this specific error. Property gallop does not exist on type bird or horse. So how do we fix this, right? In order for us to fix this type error, we will need to not use the concept of narrowing or using type guards. In this case, I will be applying the in operator. So it's the same code like before, but in this case, we change the function called move and basically narrow it down to the type that we need. So in this case, I created an if-else statement, which basically asks if gallop is in, if gallop is which is a property is inside the animal. So if it exists in the animal, then we can return the gallop. Then we know that the animal is a horse. Else, if it doesn't exist in the animal, we can discern it as a bird. So we can run the fly method instead of running gallop. So this way, we won't be able to see more errors because we specifically narrowed it down to the specific type that we need in order for us to run its own or access its own properties, right? Other solutions could be using instance of, which is another type guard, and using predicates. For instance of, we will just simply check if the animal is an instance of horse. So in this case, we narrowed it down to the specific type of the animal that we pass. So we can now run gallop and we can now run fly because we're only passing two union types or one union type of horse and bird. Okay. The next, we can create a custom predicate, which is another function. In this case, I created if it is a horse. Basically, we're passing a union type of animal. Then we are returning if we are asserting if the animal is a horse, and if it has a gallop and it's not undefined, then it is a horse. We're returning true. Else, we are returning false. Okay? So that's what we call custom predicate. Problem B, circular dependencies. In this example, I created two interfaces, one for author and one for book. At first, it seems fine, but as you can see here, the author has ID, name, and books, which is uh, a type of book, an array of books, basically containing the book, but it's in an array format. And the book itself also has ID, but the difference is it has title, and lastly, it has an author, which is basically we are referencing the author itself. So basically, what will look like for the object is it. Say for example, you have an author, it will have a list of books in it, and each of those books has its own author containing this looping circular dependency. So how do we resolve this issue? One way is using the ID-based relationship. So instead of us storing the object in the interface, we are storing the IDs of the object. So in this case, I changed the books from books to book IDs, which contains an array of a number. It could also be a string, however you wanted the ID to be. But in this case, it's a number. These numbers are foreign entities or foreign keys for the book itself. Then I created the book itself again. Then change the author from referencing this interface to just simply containing the ID of the author itself. So in this case, we are breaking the circular dependencies by using IDs. Problem C, nested types. This stems from the readability issue. So we have here an interface called company, which basically contains a whole lot of nested properties. Like in departments, it has an ID, name, and it also has employees, ID, name, roles, etc. So I think this stems from the fact that it doesn't look good in the eye, and it's pretty complicated to actually pinpoint where the issue comes from because this is just one single interface. So the fixes for this is probably separate or basically divide this interface into multiple interfaces. So that's probably the fix. Now, in order to fix this, we created 5 interfaces which we could get from this one single interface from this one. So in this case, it would be much easier for us to find the problems wherever it may arise because we don't really we have 5 different interfaces. We could pinpoint which part of the object has an issue, right? Instead of just having one interface, it will only point to one interface. If, for example, we have an issue with the types. So that's the possible reason why we need to separate this object into multiple interfaces. Now for other solutions, they're all similar. But in this case, for the second solution is instead of actually defining the interface for permission, we can just use type aliases. So in this case, we created a permission, which is a type instead of an interface, which has properties read, write, and execute, and they're all booleans. So that's what we could do. Then next, we could actually modify or manipulate the whole object itself. We flatten it, right? So instead of us actually creating multiple interfaces, we just create one interface. So that's one way to resolve this, right? Other practices. These are the other best practices to improve your code quality. So instead of just more of on the beginning side, we will tackle more on the intermediate side of things. on how we could fully utilize the perks of TypeScript in our projects, right? Of course, first we have what we call the generic types. So in this example, we have two functions, right? A get first number and a get first string. Get first number accepts a parameter called numbers, which is an array of numbers, and returns a number. Then the get first string is the same thing, but instead of dealing with numbers, we are dealing with a string. So actually, these two functions is already good, but we could make it much better if we want to deal with multiple data that has a similar structure but different types. So in this case, we can employ generics. By combining these two functions with generics, I created a function called get first item, which accepts a parameter of items, which is of type T, denoting generic, and an array of T, so meaning that it is an array of the generic type. Then it also returns the items on or the first index of that item. So it also will return a generic type. So that's how we could utilize generics in our project. Basically, we can pass any type which is an array here in this get first item, and it will basically just return the first index of that array. So that's the power of generics. Number two, utilizing read-only to prevent mutations. So read-only are properties that allows us to prevent mutations over a variable. So when we initialize, say for example, a variable with a value already, and say for example the value is 1, and we try to change it to 2, with read-only we won't be able to do that. So in this example, I created an interface called config, which has two properties, which is API URL and timeout. Both are in read only, and we created another variable called config, which is of type config, and we're passing the initial value for this. So in this case, the API URL and the timeout is initialized. Now, when we try to change this via config.api URL is equal to, say, for example, a new URL, we will be able to have an error saying that we cannot assign API URL because it's in read-only property. Meaning that on first initialization, we can store a property there or a value there inside that property, but we cannot mutate those values. So this is very helpful when dealing with IDs as well. So I think we should employ this. Next are conditional types. The basic gist of this is defining types conditionally. So in this example, I just created an interface called animal, which has a method called live. Then another interface called dog, which extends that animal, which is also another method called wolf. Then lastly, an interface called robot, which has a property model and a method called perform task. Then at the bottom, here we have the conditional types. We are basically we created example one, then its value is if dog extends to animal, meaning if dog does extend to animal, its property is of type number. Then else it's a string. So basically this is a type, but its type will be defined based on this condition, right? That's the basic gist of conditional types. Second example, the same thing, but in this case, we are comparing a regular expression if it extends to animal, which is gonna be false. Therefore, the value or the type of example number two is a string. Then next, for example number three, I created uh, a property called a type called robot of, which accepts a type or a generic type. Then we are comparing that if that type extends or contains a model property, then we will return the type of that model. Else, it will be an animal. So, in this case, I created an example tree, then use the robot of type and pass the type of robot. So, I passed this interface robot, which contains a model, and this robot of basically checks if it has a model which is definitely true. Then it returns this, which is robot, particularly the model property of robot. And it returns the type of that. So what's the type of model? That's a string. Therefore, example number 3 is of type string. And if it doesn't have a model property, then this will be an animal. So that's conditional types. Then lastly, discriminated unions. So in this example, right, we have two interfaces, which is one, the square has the type property and the size property. Next is a circle, has the same type property and the radius property. Then the basic gist of discriminated union is we create a type called shape, which basically contains all of these similar looking types with common properties into one. So the shape has the square and circle, and both of these has their own property type, right? Then I created a function which is called area, which accepts a shape type. Then it checks if shape.type is equal to square. Then it will return the size multiplied to its size again. So that's how we use the discriminated unions for us to basically unite or unify some separate or multiple different interfaces with common properties. Now for the takeaways or summary. Types, basically it defines the kind of values that functions, variables, or other data can hold. Next, type annotations. TypeScript lets you explicitly declare the types. That's one of the features of TypeScript. Next is structuring. This is the way we could create our own types or custom types. So we have the concept of type aliases, which is a way for us to create types with properties. Then interfaces, which is just similar to types, to type aliases, but with a few quirks to it. Then I haven't tackled other ways for us to structure, such as classes. But yeah, I guess you'll just have to figure that out. Next, we have the concept of type checking or static type checking, which is a feature of TypeScript. Basically, it checks the type at compile time, preventing errors like assigning a string to a number variable. Yeah, basically all of those things are under static type checking. Next is the concept of inference or type inference. So TypeScript can automatically infer types based on the initial value. Say you have a property called value and you assign a number to it. You don't really need to explicitly say that it's a number or explicitly include the type there. You just need to just initialize it with the value, then TypeScript can infer it. Next, we have the type assertions, which is basically a way for us to tell TypeScript that it should treat a specific value as a specific type. So you have a variable called value, and it's say for example it's a number. Then to use assertion, we just say that value as number. Then that's the way we could assert that it's a number. Next is the common practices, right? We have the concept of narrowing, which is the process of refining a type of variable within a specific scope. This is similar with type guards, right? So basically, if we are dealing with a bunch of like union types, we could use or apply the concept of narrowing for us to specifically avoid type errors. Then we have the concept of type guard, which I said is similar to narrowing, but these are expressions that check the type of a variable. There are a few. We have type of, instance of, key of, in, etc. Then next we have generics, which is basically allows you to pass types as parameters. This is very helpful for dealing with a bunch of types. But like we have, let's say, a process function, we could use generics to process multiple types. Then we have the read only, which is a way for us to enforce immutability within data. This is specifically helpful with when dealing with IDs of, say, for example, you are dealing with API, which basically returns you the ID as well. So you don't want that ID to be changed at the front end, right? So we could use the read only to enforce immutability. Then next, we have conditional types. Basically, these are the types that let you define types that depend on other types, which is useful for advanced type transformations. So these are the types which are conditionally dependent on the conditions that you put to it. So its type is not it's depending on the condition that you put to it. So I've given you an example earlier. You could just review this. And yeah, lastly, we have the concept of discriminated unions. Basically, these are the types with common properties. This is basically used to distinguish between union types. So basically, there are, let's say, for example, we have two different properties, but with common, two different interfaces with common properties. We could create a union type. Then we could, with that union type, we could use the concept of discriminated unions to specifically narrow it down to a specific type. So those are my techniques that I use in my day-to-day for TypeScript development. If you have any questions, please drop it down below in the comments. I'm open to answering all of your questions. Hopefully, I'll be able to. And yeah, if you have like no more questions, I guess, yeah. Thank you for tuning in, and I hope to see you soon. Thank you again, guys, for joining us. If you enjoyed this talk, please be sure to follow us on Facebook, Instagram, LinkedIn, YouTube, and TikTok at KodeAcross. Also, check out our website at KodeAcross.com for more information. We want to hear from you, and if you have topics you'd like for us to cover or want to join us for our live tech talks, just comment down below. And yeah, let's build meaningful apps that change the world. Thank you, everyone. Hi, guys. If you have any questions, guys, just type it in the chat box down below. I'm free to answer them. Okay. Seems like no one's asking questions. I guess. Yeah. I guess my presentation is clear already. Yeah. Hopefully. Okay. Yeah, I'll give you about like 1 minute, guys. I'm open. Okay. Okay. I guess that's it. I think no more questions from the people. Okay. So yeah, thank you, everyone. Again, that's the third time I said thank you. But yeah, if you enjoy this talk, guys, just be sure to follow us again on our Facebook, Instagram, LinkedIn, YouTube, and TikTok at KodeAcross. And yeah, if you have any topics you'd like for us to cover, just message us in our Facebook page. Yeah, and hopefully in the future I'd be able to share more information to you all about technologies that I have learned, and hopefully I'd be able to translate it to you guys in a way that's more informational or bite-sized, so that it's much more consumable for the larger audience. So yeah, let's build apps. Let's build meaningful apps that change the world. Thanks again, guys.